Mars, the fourth planet from the Sun, a world that has fascinated humanity for centuries, appears at first glance to be a place of limitless potential. But beneath the red dust and the allure of adventure lies a landscape that is, frankly, a disappointment. A dead, cold hellscape, hostile to life as we know it. There is almost nothing on Mars that we need to survive. No breathable air, no liquid water on the surface, no fertile soil for crops, and barely any magnetic field to shield us from the sun's relentless radiation. If we were to go there now, we'd be forced to hide underground, clinging to life in cramped artificial habitats, eking out a miserable existence for a handful of brave astronauts at a time. But what if we could do more than survive? What if we could transform Mars into a thriving green world, an oasis for humanity, a second Earth? To do that, we'd need to terraform the entire planet to fundamentally reshape its atmosphere, its surface, and its very nature. And as strange as it sounds, the first step would be to make Mars even less hospitable. By using technology on a planetary scale, turning its crust into a molten ocean with the power of giant lasers. This might sound like science fiction, but the idea of terraforming Mars, radically changing its environment to suit our needs, is not as far-fetched as it might seem. In fact, the time it would take to achieve such a transformation is less than the span between the building of the pyramids and today. If humanity can overcome its biggest challenges and take its first steps into the wider solar system, the dream of a living Mars could become reality within a few generations. So how would we go about this massive project? The answer is, it's complicated. Mars is incredibly dry, with only the faintest traces of water locked away as ice and permafrost. The atmosphere is thinner than the highest mountain peaks on Earth, and it offers no protection from dangerous cosmic rays and solar storms. To make Mars a home, we need to create a new atmosphere, one as close to Earth's as possible, rich in oxygen and nitrogen at a comfortable pressure and temperature. We'll also need vast oceans and rivers, fertile soil, and, ultimately, a living biosphere teeming with plants and animals. Add to this the need for long-term safeguards against cosmic hazards, and the scale of the challenge becomes clear. Yet if we start with a giant laser, the path to terraforming Mars opens up in unexpected ways. Let's start with the first and greatest obstacle, the atmosphere. Billions of years ago, Mars wasn't so different from Earth. It had a thick, oxygen-rich sky and surface water, oceans, lakes, even rivers. For hundreds of millions of years, the climate was stable enough to support these features. But everything changed when Mars lost its magnetic field. Without this shield, the sun's ultraviolet radiation broke apart atmospheric gases and stripped them away. The oceans evaporated, and solar winds blasted what remained into space, leaving behind the barren world we see today. But all hope is not lost. Hidden beneath Mars's surface and frozen in its polar caps is enough water to create a shallow global ocean. Even more tantalizing, the oxygen that once floated free in the atmosphere is still there, locked away within Martian rocks as iron oxides and carbonates. To free these gases, we need to reverse the chemical reactions that trapped them. This means heating the planet's surface to temperatures rivaling those on the Sun, a feat only possible with immense energy. That's where our giant laser comes in. By placing a constellation of solar-powered lasers in orbit and focusing them on the Martian crust, we could heat the surface to the point where oxygen and other gases are released. The most powerful laser on Earth today, capable of delivering 10 petawatts in the blink of an eye, pales in comparison to what we'd need. A continuous beam, twice as strong, covering vast swaths of the planet. Massive mirrors in space, covering an area larger than the United States, would concentrate sunlight, powering these colossal lasers. As the lasers sweep the surface, the Martian ground would begin to melt, releasing oxygen and carbon dioxide into the thin air. The planet would glow with molten rivers of lava, storms raging in the sky, and clouds of ash billowing upward as the crust cools and solidifies. It would be a terrifying and awe-inspiring spectacle. But as the chaos subsides, a strange new world would emerge. Water from the polar caps and buried ice would vaporize, raining back down to cleanse the surface and collect in shallow seas. Toxic gases would be washed away, leaving behind a cleaner, more hospitable environment. After about 50 years of relentless effort, the atmosphere would be transformed, rich in oxygen, but still dangerously thin and flammable. To create something truly Earth-like, we'd need to import vast amounts of nitrogen, which Mars almost entirely lacks. The best source is Titan, Saturn's largest moon, whose nitrogen-rich atmosphere could be harvested by automated factories and shipped to Mars in enormous bullet-shaped containers. These would be launched across the solar system and detonated in the skies above Mars, mixing with the existing air to create a safer, more breathable blend. With the right balance of gases achieved, and maybe a little help from greenhouse chemicals if the planet is still too cold, Mars would become a world with blue oceans, black volcanic plains, and patches of rusty red terrain. A blank canvas ready for life. But life is fragile, and creating a biosphere from scratch is daunting. We'd begin with the oceans, seeding them with hardy phytoplankton that could fill the water with oxygen and form the foundation of a new food web. Zooplankton, fish, and eventually larger creatures would follow, each introduced with care to maintain balance and prevent collapses. The land would be tougher. The newly cooled crust would be little more than volcanic rock and ash, nutrient-poor and inhospitable. We'd need to speed up the creation of soil, using our lasers to shatter the stone into fine dust, then introducing fungi and bacteria that can fix nitrogen and break down minerals. Over time, this black mud would become fertile enough for plants, starting with those adapted to volcanic islands on Earth. Grasses, shrubs, and trees would take root, their roots cracking the ground and drawing up nutrients, slowly building a self-sustaining ecosystem. As forests spread and animals are introduced, Mars would finally begin to feel alive, though the process could take centuries to stabilize. One great challenge would remain: Mars's lack of a magnetic field. Without this shield, the planet's new atmosphere would be vulnerable to the same fate as the old one, stripped away by the sun's relentless wind. To protect our new world, we'd need to build a massive artificial magnet, perhaps a superconducting ring floating in space between Mars and the Sun, powered by nuclear reactors and designed to bend the solar wind away. With patience, technology, and effort on a scale never before attempted, we could transform Mars from a barren wasteland into a home, a world of air, water, and life, shaped by our hands, ready for new generations to explore and cherish. It would mark our first true step beyond Earth, and the beginning of humanity's adventure among the stars. Did you find our videos helpful? Please like and subscribe to our channel so we can be motivated to answer the questions that people are still wondering about.